Hello folks, grade 11 trigonometry is our starting point for this grade 11 series. As I said, I do this according to the requests that I receive. So I will start with this, and the aim of this is to be able to solve or simplify rather trigonometric expressions and even equations. So I'll just start off by reminding you what you already know from grade 11. If I've got the Cartesian plane there and this is my triangle, first thing that you know if you want to complete your triangle is that the angle there is 90 minus theta using the sum of angles in a triangle. I explained this in the introduction to trigonometry series for grade 10, so you may want to catch up if you have forgotten a little bit. And then the other reminder is your SOHCAHTOA. You know this again, that sine of theta in this triangle will be opposite over hypotenuse. Cos of theta will be adjacent over hypotenuse, and the tan of theta will be opposite over adjacent, of which in this case, if I've got this side as x and this one as y, and the hypotenuse as r, this will be y over r, x over r, and y over x. Now, something that I'd like to show you quickly, which again, you probably know, but it's good to always refresh and repeat stuff. Repetition is a learning process. If I now, I'm in the position where I'm at 90 minus theta. So in other words, if I'm here on this angle, then sine, which is opposite over hypotenuse, my opposite is now x, and hypotenuse remains r. If I look for cos 90 minus theta, that then becomes y over r, because for this angle, the adjacent side is y. And finally, for tan 90 minus theta, then the opposite in this case is x, and the adjacent is y. Actually, this is just 1 divided by y over x, which is what we had here when we were looking for tan theta. And you know this is actually the cotangent of theta. But what I want to draw your attention to, which I hope you would have realized, is that sine 90 minus theta is actually cos theta, because cos theta is x over r, and that's what we got there. Cos 90 minus theta, which is y over r, is also the same as sine theta, which is y over r. So we can come up with a nice conclusion here. We know that in trigonometry, this is actually true, because we just proved it using a triangle. There are other ways to prove it, but this is just the most easiest actually. So that we know, cos 90 minus theta is sine theta, and tan 90 minus theta is cot theta. These are important. You're gonna see a lot of them when solving trigonometric expressions. So I thought I should start that with that, and then hoping that you will get the gist of this and you will survive with it. So I will, I think I'll stop this video here so that it is not that long and tedious for you. In the next video, I will then deal with special angles. We will look at the 3 special triangles and deduce some results from those triangles. The special angles are also important for solving trigonometric expressions. In terms of speed, we need those, and we also need those for our NBT. You want to be admitted into university, you've got to know them very well, because you will not be writing with a calculator. And it's really nice and convenient when you know these things off by heart than having to rely on your calculator now and then. So what are we taking from this lesson? We are taking the very first important, or one of the important identities, if I should say, that we need to know, is the fact that as tan 90 minus theta is cot theta, sin 90 minus theta is cos theta, cos 90 minus theta is sine theta. That is the first identity that I'd like for you to know. And maybe to throw this one, I want you to go and investigate what happens if I do this. If I take y over r, okay, and I divide it by x over r, okay, what is the answer? We will also cover that later on. I hope you see where it is leading. Cheers.